I'm Max Doolin. I'm the founder of the Spokane Cyber Cup, and this is the Amazon CTF Challenge from the 5th annual event. So, as always, we'll start by reading the challenge. The goal is to break into Jeff Bezos' personal account. We have the password. Now we need to guess his OTP. Hint how OTP is generated. For those who don't know, OTP stands for one-time password. And these are common for things that are somewhat security sensitive, where just in the case that somebody compromises your password, you don't want them to be able to log into your account. You want to have other means to protect against that. So OTPs, or one-time passwords, are usually implemented as numbers. It could be like a Google Authenticator app. It could be an SMS text message that has a number in it. There are a lot of different ways to implement this. So being able to bypass OTPs is really important. Is a good skill and a important attack vector. A lot of times this can be used to reset passwords on a given account. So for this, we need to SSH into the box, and I already have a setup for this going. So I guess I can show the SSH. I don't know the actual port's going to be yet, but the username and password are always going to be Amazon. And for a given challenge, the username and password for SSH will always be the same. So if we do /Amazon, we run it, we'll see that we have two options. We have create the OTP and check the OTP code. So if I create an OTP and then I check it to be like 1111, it failed. This makes sense. In order to see why this makes sense, we can actually just look at the code though. So we can see the field that checks an OTP attempt. We can see the function that creates an OTP, and we can see the setup, and we can see the actual loop for this. If the check OTP attempt succeeds, we get the flag. Otherwise, we don't get it. When we create an OTP, it's taking a random number from 0 to 9999. So that means that there are exactly 10,000 possibilities. It is then converting this to a string, and it is creating a file that is that. So for every challenge or every user that logs in and attempts this, when you're doing the /Amazon, it creates a folder. And that folder that is there for a given user is where we're logging at. So when it's taking the directory folder, that's what that means. So it's doing directory folder. It's going OTP user specific directory folder, and then it's creating a file with OTP string. Now when we check the OTP attempt, it's just iterating through all of these files and checking to see if the timestamp within that file is less than 3 minutes ago. So that gives us about a 3-minute time window to do attempts. Now, if you're looking at this, there's probably there's two main ways to solve this. There's the intended solution and kind of just a fallback of how things work. So the first one is that there is no limit on the amount of OTPs we can create. Because of that, we can create all of the OTPs and then guess a random number, and it's probably going to work. That's pretty nice. The other thing we can do is we can create a single OTP and just iterate over it and check every single possible OTP until we find the right one. These are both brute force attacks of sorts, where we're going to do we're going to either completely fill the space because the space is really small, or we're going to try every single thing. And with OTPs, it's tough because you want the OTP to be easily typable on a computer when you're like logging into Facebook, but you also don't want it to be too small because then it can be brute forced, which is why rate limiting or brute force protections are really necessary for this. So I'll probably add a hint for this, but the easiest way to solve this is to use Python and just print something really quickly. So if we do python-c, it will run something in the command line. We can do 1/. And if we do that, then we get 1 that's printed. But this 1 is used for creating the OTP code that you can see here. So what we can do instead is we can do 1, and we can do like times 30,000. And this creates a lot of 1s. And now we do that, we can do plus 2 slash, and this will check the OTP. And if the OTP is correct, then we'll get the flag. So you can see we have a bunch of 1s and then a 2. Now if we do /Amazon, and we let this run, you'll notice that we can now get the flag. Woo! All you have to do is create a large amount of OTPs. Now for the other solution, with just brute forcing it, I'm just gonna write a quick script here. So I'm gonna do for I in range 0 through 10,000. And I'm just going to say print I. And print 1, because we want to print the option 1 when we do this, and we want to have a given attempt. So we have to enter 2 numbers for this. No, it should be 2, because 2 is that option. My bad. So if we, again, go to Amazon, 1 is create OTP, 2 is check OTP, and when we check it, we need to enter the exact token in. When we enter a token in, we want it to be correct. Now, I just realized I'm not sure why this works. I'm guessing it just exits, and because the empty OTP is there, that works. I was expecting to have to do something like this. Have that be correct. Oh well, I'll figure that later. So if we do python/temp and whatever that is, then we're gonna do 2 try number, and I can just pipe that into Amazon. And eventually we might see, I'm gonna pipe that into Amazon, but then I'm also gonna do the output here. But there's actually a small mistake I just realized in this. First, we need to just print 1, which will generate a single OTP, which is all we need to do. This is more of a classic brute force attack now. So I'm going to do /temp output.txt. And if we go to this, if we look for SC3, most of the flags there. That's pretty nice. Cool. Well, that's the CTF challenge. Thanks for looking at it. Let me know if you have any questions.